Hello students, today we'll come to know about Le Chatelier's principle. So let's understand its definition. It states that if dynamic equilibrium is disturbed by changing the conditions, the position of equilibrium will shift to counteract the change to re-establish an equilibrium. So, how does the concentration change affect the equilibrium position? So, when you add one or more of the reactants or products at the equilibrium position, the system is no longer in equilibrium. Now, the position of equilibrium will move toward that side to reduce the effect of increase in concentration of reactant or product because the reaction or the system wants to re-establish the equilibrium because whenever some stress is applied on that position when the thing is stable, then it wants to re-establish that stability. So same thing happens to the system or the reaction mixture. When you add some reactants or the products, the system is disturbed and now the position of equilibrium moves toward the reactant or the product side to re-establish the equilibrium. So what happens when you add more reactants? When you add more reactants, then equilibrium position shifts toward forward direction. And when you add more products, obviously the product side concentration has been increased and it wants to re-establish the equilibrium. So therefore, the equilibrium position will shift toward reverse direction. Now, what happens if you remove the reactants? So, equilibrium position will shift toward the reverse direction. And if you remove the products, again equilibrium position shifts toward forward direction. Let's understand this thing through an example. So this is the example, and as you can see that acetic acid is reacting with ethanol to form ester and water. Now let's understand this example. If you add more ethanol, it means you are increasing the concentration of the reactant. And the concentration of ethanol has been increased, and according to Le Chatelier's principle, some of the ethanol must be removed to reduce the concentration of added ethanol, and the position of equilibrium shifts toward right. So more ethanol reacts with ethanoic acid, and more ethyl ethanoate and the water will be formed. Now, what will happen if we add more water? If we add more water, it means the product concentration has been increased. So, what will happen? The concentration of water is increased. So, according to Le Chatelier's principle, some of the water must be removed to reduce the concentration of added water. So, the position of equilibrium shifts toward left. Now, what happens when we remove more water? It means you are decreasing the concentration of the products. So, when you decrease the concentration of product, what will happen? Basically, due to decrease in concentration of the product, according to Le Chatelier's principle, some of the water must be added to increase its concentration. So, the position of equilibrium will shift toward right. Now let's understand the effect of change in pressure on the equilibrium position. So, first of all, keep this thing in mind that the change in pressure will affect only those type of reactions in which reactants or the products are gases. So, because the molecules or ions in the liquids or solids are packed so closely together, so they cannot be compressed easily. So, by applying pressure will not affect solids or liquids as much as it affects the gases. So, in gases, the molecules are fall apart and we can compress the gases. Now, what will happen if we increase the pressure? So, this is the example. Here are the gas molecules. When you increase the pressure, it means you are increasing the concentration. And if you are decreasing the pressure, you are decreasing the concentration. Now, let's suppose that we increase the pressure. So this thing you should keep in mind that when the pressure is increased, the equilibrium will always shift toward that side of the reaction where the gas molecules are fewer. It means the equilibrium will shift toward that side in which there are lesser number of moles of the reactants or the products. Now, if we decrease the pressure, now decreasing the pressure will shift toward the side with more gas molecules to increase the pressure. And now, if there is no change, it means that number of moles of the reactants and number of moles of the products are equal. Now let's understand it through some example. Now let's understand this thing through an example. So for example, if we are having SO2 and it is reacting with O2, so it is forming 2SO3. Now you can compare the number of moles of reactants. The number of moles of reactants are greater than that of the products. Now if you increase the pressure, now equilibrium will shift toward that side in which the number of moles are lesser. So you can see over here that out of the reactants and the products has lesser number of moles. So obviously equilibrium will shift toward product side. It means equilibrium will shift toward forward direction. And if you decrease the pressure, it means that the equilibrium will shift toward that side where the more number of molecules are present. So it means that if you decrease the pressure, equilibrium will shift toward reactant side, or you can say it will shift toward reverse direction. And the effect of temperature on the position of equilibrium. Now what will happen? That if the position of equilibrium in the chemical reaction is influenced by temperature changes due to some Le Chatelier's principle, and which states that a system at equilibrium will adjust to counteract any imposed change. So what will happen? So this all depends upon either our reaction is exothermic or endothermic. Now let's understand how the temperature change affect the exothermic reactions. So as you know, in exothermic reaction, heat is released and we can write it on the product side. Now, what will happen if you increase the temperature? By increasing the temperature, the equilibrium position will shift toward the reactant side. Why? Because as you know, if you increase something on the product side, it means that it will go toward the reverse direction to readjust the equilibrium. So therefore, system tries to absorb the excess heat. And what will happen? If you decrease the temperature, then equilibrium will shift toward right to release more heat. Because now you are decreasing something from the product side. You are decreasing something from the product side. Now let's understand the endothermic reactions and the effect of heat on the endothermic reactions. Now, as you know, that heat is absorbed in endothermic reactions. So therefore, we can write the heat on the reactant side. And if you increase the temperature, it means you are adding something on the reactant side. And when you add something on the reactant side, it will move toward the forward direction. So it will shift the equilibrium position towards the right because the system absorbs the additional heat. And what is the effect of decreasing temperature? Basically, it will shift the equilibrium position toward left as the less heat is available. Now there are some review questions. Now you have to predict the increasing and decreasing the pressure on the following reactions. So as you know, in the first example, the number of moles on the product side are greater than that of the reactant side. So it means in the first example, if you increase the pressure, what will happen? The reaction mixture will re-establish the equilibrium toward the reactant side, and the equilibrium position will shift toward the reactant side if you increase the pressure. And if you decrease the pressure, the reaction will move toward the forward direction. Now talk about an example. As you know, CaCO3 is decomposing to CaO and CO2. Now you can see that here the number of moles on the reactant sides are lesser than that of product side. So same thing happened as in the first example. Now here again the same thing is here, that the number of moles of the product are greater than that of the reactant. So you can predict what will be the effect of increasing or decreasing the pressure on the following reactions. And tell me in the comment box that what are your answers for these following reactions. Thanks for listening and watching my video. And don't forget to subscribe my channel.